The cargo lines on a gas carrier are the liquid lines, vapor lines and the lines to the vent riser. These lines have the same requirements as the pressure vessels regarding the temperature and pressure they should be able to handle. Cargo lines less than 25 mm in diameter can be connected with threads. All cargo lines with diameter exceeding 25 mm must be flanged or welded. All welding on pipes, flanges and spool pieces exceeding 75 mm diameter and 10 mm wall thickness must be X-rayed and classed. The material used for cargo lines outside the cargo tank must have a melting point not less than 925 degrees Celsius. Cargo lines that are designed for products less than -10 degrees Celsius must be insulated from the ship's hull, to prevent the ship's hull being cooled below design temperature. All thermally insulated lines must be electrically bonded to the hull with steel wire or steel bands. On each flange on lines and pipes where gaskets are used, there must be electrical bonding with steel wire or steel band from flange to flange. All cargo lines that might contain liquid must be fitted with a safety valve. Vapor from the safety valve outlet must pass to the cargo tank or the vent riser. The pipe leading to the vent mast must be equipped with a liquid collector to prevent liquid going up the riser. The hull has to be protected against cold cargo spill under spool pieces and valves. This is done with planks or plywood. To prevent cold cargo spill on the hull plates, a drip tray is placed below the manifold flanges. Manifold connections are fitted with strainers for loading and discharging. The strainers are intended to protect cargo handling plant and machinery from damage by foreign objects. All the pipework connections to tanks beneath the deck must be through the cargo tank dome. The tower which supports the pipework within the tank is constructed of stainless steel bars. If subjected to rapid cooling, thermal stress within the material can be excessive, leading to the material cracking. Gas tankers utilize ball, globe, gate or butterfly valves. The valves are usually fitted with pneumatic or occasionally hydraulic actuators. Valves must be fire-safe type. The Type C cargo tanks are required to have double valves on all liquid and main lines except relief valve connections. This double valve arrangement comprises a manually operated globe valve in series with a remotely operated isolation valve. Type A, fully refrigerated, and Type B, non-membrane LNG, tanks must have shut-off valves for liquid and vapor connections. These valves must be capable of local and remote operation. IMO codes require at least 2 pressure relief valves of equal capacity to be fitted to any cargo tank greater than 20 cubic meters in capacity. IMO codes also require for all pipelines or components which may be isolated when full of liquid to be provided with relief valves to allow for thermal expansion of the liquid. These valves can relieve either into the cargo tanks or to the vent riser via liquid collecting pots. Less than 20 cubic meters, 1 PV valve is enough. Spring-loaded relief valves are used on Type C tanks only. Pilot-operated valves are found on Type C, B and C tanks. Pneumatic vent valves or electric push buttons are provided at the cargo control room, compressor room, gangway, bridge front and emergency control stations. These switches when operated close remotely operated valves and stop cargo pumps and compressors. Emergency shutdown should occur upon loss of electrical or control power, valve actuator fail-safe, and fire at the tank domes or manifold, via suitably located fusible elements. Individual tank filling valves are designed to close automatically upon actuation of an overfill sensor in the same tank. The possibility of surge pressure generation exists when the ship's ESD system is activated during loading. The situation varies depending on characteristics of the terminal and is a function of the loading rate, the length of the pipeline, the closure rate of the valve and the type of valve. The effects of surge pressure can be extreme and affect harm loading arm joints or rupture hoses or even cause movement in the loading line. Terminals may need to check ship manifold valve timing. Loading rates and/or valve times may need to be adjusted.